just about that. Okay, cool. All right. Yeah. So, how have you been?
Good. I just finished attachment for a week.
Are you not going back on Saturday? Like,
And
was it just
attachment ended already.
from? Was it just Monday to Thursday?
Yeah, yeah.
Just four
Started last.
days. Okay. Okay.
No, days.
Okay. Why don't we start by, like you telling me, because by now, have you started thinking about a personal statement yet? Because for you, personal statement will be very important, yeah. So have you started thinking about personal statement, like how you're gonna draft it and stuff?
I I haven't actually really started yet.
Like I said again, personal statement very important to you, yeah. But anyway, let's go through a few points, I suppose. Do you know why you want to apply to Oxford? Like if you're asked this question, why this particular university?
Well, I know for a fact that Oxford is a top competitive university out there. So I just want to challenge my intellectual with other students. I want challenge so that I want to be a really good biochemist by the time I enter Brunei when I graduate and when I
Okay,
yeah
so where do you see yourself in 5 years time, let's say?
I see myself as a biochemist working at our hospital in Brunei, the Ribas Hospital. I see myself working in a lab with colleagues and solving cases, I guess, and just running lab works, I guess. And
So, go on.
so that's it.
You should come up with a better structured response, yeah, just in case, because that was quite awkward actually. I know it came out of the blue, but by the time you're ready to submit your application, which is in very soon, yeah, like 1 month time, way before exam, you should finish everything already, because there's no point of like rushing through things. Essentially, finish everything by October. Um, you should have gone through a couple of drafts of your personal statement, uh, not all at one go, because otherwise you would be, receiving changes from a lot of people at the same time. It's better to like one draft, one person, and then the next draft another person, and the next draft another person. Then at the end of it, it's just incremental improvement from time to time. So different people will have different perspective on personal statement, and I would say like the book on how to write a good personal statement is quite nice, and they give you examples of personal statements for people who are applying to science courses, as well as people who are applying to like humanity courses, and you can see like what kind of thing they put in there. And I think in general, like a lot of tutors, they are used to seeing a general form of personal statement, but in order to make yourself more authentic and also to make your application as strong as possible, you should really come up with something which is your personal statement, but something which is carefully researched upon as well. For example, like you see yourself in 5 years working in labs, in hospital, you say. So those are general things. Those are general statements. And even if you write that your personal statement, it's still really general, like from if you say you've done a work experience like these 4 days, so why don't you tell me like what is the biggest takeaway point, or what are some of the biggest takeaway points from your 4 day short working experience in the hospital?
Well, for me, I didn't really take much biochemistry point because most of the things we did and we were shadowing doctors and we never entered any labs. But I
Okay,
guess for me, the biggest thing I took from the attachment was that in Brunei we are lacking doctors and basically manpower in the hospital, whether labs or doctors. I mean, or specialists or dentists or yeah, anything in general. Yeah.
I am assuming you'll be applying for medicine university, right? UBD.
Yeah,
Okay.
I'll be medicine too.
Will you be applying for dentistry as well, everybody, or maybe because I think you're only allowed to
Uh,
choose one, right, rather than both.
I'm not applying for dentistry. I'm not really interested
Okay.
in the field.
Okay. I'm not sure Sir Charles has told you, but there should be a scheme coming out. That's for the Auckland slash Otago
Oh yeah,
medical scheme. Oh, have you guys been informed about it? Are you
yeah.
applying for that?
I haven't really checked it out yet, but
Oh,
I'm planning. Yeah,
but you guys have been told about it, right?
yeah. He messed.
It's yeah, it's worth it.
Mm.
You guys will be interviewed. I think like all the applications to be in like essentially in like before October actually. So one of my former students is actually in Otago now doing dentistry, and she didn't get straight A for June S, unlike you guys. But she did score like A star AA in her final A level. So it's possible. And then like usually like if you don't get 3A minimum, they don't even ask for a star. If you don't get 3A minimum, automatically, even if you are accepted, you'll be rejected straight away. So this is straight from the scholarship department. They get your result from the exam department as soon as they're released, and then they will you will start much earlier. You will start like in February next year, like February or March next year. As soon as result release, gone. If you get it. And every year there are quite numerous, and we just don't know how many people apply, how many people are applying. But this will be medicine from year one in New Zealand, and it's if I were you, I would say like submit an application and see how it goes. You will still get all that mini multiple interview, MMI and stuff as well. And I think if I'm mistaken, if you've done it once for this application, then you don't have to do it again for the UBD one. Presumably, like they just say, like, you just need to do one time MMI, and that's why for every single interview you need to cherish the opportunity. Yeah. Okay. And just like anything in real life, if it is a big thing and a lot of competition, you need to be more prepared. Okay, like your structured responses and things. I'm not saying like go in like with full scripted answer, but you should have a better idea of like what to say first and how to say it properly and clearly, without being too general. Because at the same time, you want to make yourself unique. What are what are your selling points? Yeah. Okay. What makes you special? So out of this, let's say in general, I know you're going to apply for medicine because you say, mentioned about this experience working in a hospital and things. How are you going to justify yourself applying for like a course in biochemistry? So you need to make a distinction between the working experience, shadowing doctors, which is different from like what you'll be doing as a biochemist. But it's all right. I mean, but the way you structure application and your personal statement, put it in a way where you were not just shadowing doctors. Like, what else did you learn from them? Like, for example, medical research, the things they do, right? How do they know what to do, or what are their basis for what they do? Because there were precedents for it. What kind of precedents? Prior work by who? By doctors, by researchers, and they were guided by research essentially, and guided by prior knowledge, and not just like not just whatever they want to do. And there wouldn't be. I'm not sure whether there will be ethical question, but because they don't really do animal testing in biochemistry, they don't do much beside the usual mice. I know medical research is another field, is another course actually. So like there's another course called biomedical sciences. So there's biological sciences, biomedical sciences, and also biochemistry. So be aware that which one you're applying for, and be aware of the differences between the three, especially if they ask you why are you applying for this course specifically. Okay, that's what I meant by like you should different university, even though the same title course, they might have slightly different structure of the course, and they might ask you like why biochemistry. That's very general, right?
Yeah.
Why Oxford? Why this particular university? You say you want to challenge yourself intellectually. Yeah, okay. But then like how about other university? Will you not be as challenged if you are at any other university, things like that? In general, they don't ask a lot of questions like this, but as icebreaker, they might ask one or two. And straight away they'll delve into like agendas, like a certain theme of questions. I know for biochemistry as a fact, you will get a section where there will be a maths part. The maths section is always like sketching graph. Okay. So I don't have one particular question in mind, but are you okay with sketching graph? Like if I give you an equation, you'll be able to sketch a graph easily.
Sure, I guess we can try.
Can you draw me y equal to e to the x, exponential e to the power of x?
Okay. I guess it would be something like this. Can you see it? Well, wait, let me adjust it again. Let me. Yeah.
Yep, that's fine. But remember that when you sketch a graph, the most important feature of a graph would be like, the y-intercept, the x-intercept, that kind of thing. So your y-intercept here would be 1 because e to the power 0 is 1, right? Can you do y equal to e to the power minus x?
Okay.
On the same graph.
Oh, on the same graph.
Just overlay, maybe with dotted line or something, then you can see the differences.
Wait. Something like this. I'm not quite sure.
Y equal to e to the power minus x. Did they have the same y-intercept? I couldn't quite see because you had dotted line. Do they have the same y-intercept or not?
Yeah.
Okay, yep. Because when x equal to 0, it would be the same, right? Okay, cool. Can you sketch on a new diagram y equal to e to the power minus x, which you already draw, and then on that new diagram draw it again, and then draw y equal to e to the power minus 2x. Even before you draw, what should you be able to tell about the difference? Like what is immediately different between e to the power minus x and e to the power minus 2x?
One is y equals e minus 2x. The values are double. I guess.
What sort of value?
The x value. I mean
Sorry?
I mean the y value is like sort of double a bit. Well, it's not double, but it's larger.
Like what happened when you have the same increase in x? What happens to the value of y? Are they the same increase or not? Because they are larger, right? So when x increase, y increase. That's larger. Okay. In this case, when x is increased by the same amount, how does the y change?
It increase. It changes. How do I say? Like it increases more, I guess. Well, in this case, it decreases more. Yeah, it decreases more. Wait, let me just show you sketch. Wait, sorry.
Leave it behind. Yeah. Okay. Cool. Okay. So which one is the steeper one? The minus 2x or the minus x? Which one?
minus 2x.
Can you show me a graph again?
Sorry, let me just make one solid. Both is shaded. The solid one is y equals to e minus x.
Oh, actually the video quality is quite bad, you know. I don't know why the video quality is quite bad. Because it was okay with Aaron just now. Sorry, the bolded one is minus x.
Yeah.
The non-bolded one is minus. You think so?
Yeah.
So when x is greater than 0, is your minus 2x above the minus x or below it? I couldn't quite see it. Is it above or below? What do you have drawn? When x is greater than 0.
It's above.
It's above?
It's above. Yeah.
Okay, cool. Now, let's just focus on x is greater than 0. Okay? Let's focus on x is greater than 0. Happy so far? Okay? When x is greater than 0, so you have those two graphs, right?
Yeah.
And then when x is greater than 0, and then think about when x increase, when x equal to 1. Okay? When x equal to 1, what is y? Y for the e to the minus x is e to the power minus 1. Okay? So that is 1 over e. When for the other equation, minus 2x, y is equal to 1 over 2e. So which one is bigger when x equal to 1?
Y equals to e minus x. The 1 over e.
The 1 over e is bigger than 1 over 2e, right? So the minus x is above or below the e to the minus 2x? Is it consistent with what you have drawn?
No.
It's the other way around, isn't it?
Yeah.
Okay. And you see, you've got the right idea that it decreases much faster. It decreases more, right? To make it decrease more, the gradient itself must be steeper, and that's why I could see like something was wrong with it already. Like when it should have been, I don't know if you can see it. Like
Yeah.
one is steeper than the other. Okay, so this is your classic first order equation, first order differential equation. It's also very prominent in your chemical reaction where it's first order, right? Where you know it's exponential decay. But in terms of exponential decay, both are exponential decay. One is faster than the other. Yeah?
Yeah.
And why exponential is very important is because you should know logarithms, natural logarithms are very important in statistical modeling of, let's say, spread of disease. That's how molecular biologists, they model the spread of diseases. And they're saying like with one carrier, you can spread to however many people. And once you spread to however many people, it can multiply rapidly because of this exponential model that they normally use. And because the model involves exponential, they can throw at you that problem. And then from there, actually, it's more about like differential equations. So it's integration, differentiation, turning point. You know, like when you do the differentiation or when you do the integration, what does this mean? What does that mean in terms of biological context? Models are models. In chemistry itself is a lot of physics, so the model is based around physics. In biochem or biology in general, like a lot of the models, they have biological significance. So you need to think about some of this in terms of biological perspective. Yeah. Okay. I don't have one equation with me for the time being, but you can think of one reaction being more rapid than the other. Yeah. Okay. Actually, there is one equation that I need to ask you. So for a first order, so this is a bit of chemistry now. Suppose you have a red equation. Can you write a red equation for a first order reaction? First order chemical reaction. Sort of like if you have A going to B. So if you have A going to B, this is a chemical reaction. Okay?
Yeah.
Can you write a first order red equation? Suppose it is first order. You know what a red equation is?
Yeah.
Okay. So I want you to write that equation in terms of concentration of A.
For of A.
Yeah. So it's A going to B.
So okay. For first order, right?
Yep.
Okay.
So there's just one reactor, which is A.
Yeah.
Okay.
So just
So you've got red is equal to, well, the equation itself is an equation. So the equation shouldn't be red equation equal to that. It should be red equal to that. Okay.
Yeah.
You can take a paper down. So basically, the equation shouldn't be there because that itself is the red. Red itself is equal to the red constant times by the concentration of A, which in this case is first order. Suppose I tell you it's the first order, right? So if A is a reactant, can you sketch for me the graph of how the concentration of A will change with time? How the concentration of A will change with time. So I just sketch. You don't need a ruler. How the concentration of A will change with time.
A.
Sorry, what is your Y and what is your X?
This is here's the Y and here's the X.
Yeah, I know, but what is the meaning of the Y and the X? Because Y can be anything, X can be anything.
Y is concentration and X is the time.
Okay, so you're saying that because A is a reactant, so when as time progresses, more of A is being consumed, so concentration of A will go down. That is the first thing, right? Because A is a reactant. Okay, it will go down until it's used up because it's not in equilibrium. If it is in equilibrium, it will never be used up because then it doesn't go to zero. You agree?
Yeah.
Okay, so they can ask you question in equilibrium as well, like the carbon monoxide, carbon dioxide and oxygen equilibrium exchange in the equilibrium. It's always in the equilibrium. It doesn't go to completion unless you die. Then it goes to completion. Okay. But anyway, so you said there's a first order equation, is it?
Yeah.
So A concentration of A with respect to time. Okay. So if you written a red equation where it's in terms of red constant, right? So if I ask you to write the red equation in terms of how the concentration of A changes, how would you be able to write that? What is actually meant by rate of reaction with respect to the concentration of A?
Sorry, what do you say? Can you
repeat? In this reaction in this reaction from A to B, okay? So the concentration of A is changing. What do you understand by the meaning of rate of reaction?
Rate of reaction.
Yeah. What do you sorry?
How fast the reaction is.
Okay, cool. How fast the reaction is. So if I ask you to model the reaction, create a model, based on the concentration of A. So can you write me an equation or an expression relating between the rate of reaction with respect to the concentration of A? How it is changing with respect to time. So you have a red equation, yes, I already know you have that. Come up with another equation, how the concentration of A is changing with time for the red. So you said that red is defined as how fast the reaction is going. It's basically also defined as how fast the reactant is being used up, right? So it's basically referring to how the concentration of A is changing with time.
Is this what you mean?
How the concentration of A is changing with time. Okay, so it's not equal to K, it's equal to red. Okay, because red is defined as the change of concentration over the change in time. I don't know whether you've heard of that before. Have you heard of this before? Red is change of concentration over change in time. Yeah. Okay. So in this case, the concentration is red is equal to delta concentration of A delta T. Something like this. Do you agree?
Yeah.
So delta refer to change. Okay. Now we are going to talk about a bit of maths. So the change itself could also be defined as, if you have a small d now, so red is also defined as, so this is now a differential equation, something like dy over dx. Happy?
Mm.
Because
Yep.
it's a change or something over change or something, right? So it's the d concentration of A over dt. Okay. Another thing you need to make the equation realistic is that the red is defined by half, but A is a reactant, right? If A is a reactant, it is being used up. That's why your gradient will be negative. And that's why you need to add in a negative there, because you are expressing it in terms of the reactant, not the product. If it is the
Yeah.
product, then it will be positive. Can you
Yeah.
see that?
Yeah.
Okay,
Can.
cool. So this is the differential equation with a dy over dx.
Yeah.
This is a red equation. This is a red equation that also has red equal to red constant is the concentration of air. Can you equate these two equations together and get me an equation, get me an equation of like y equal to mx plus c.
Okay.
So both are equation involving red, right? Left side is red equation, right side is a differential equation. So link them together and express an equation that relates concentration of air is to time. That will give you your equation of y equal to mx plus c essentially.
Okay.
Do you know what to do? Or do you need a bit of help?
I'll think first. Mm, mm,
In this interview, yeah, because it's Skype interview, while you are thinking, while you are working through problem, they are not seeing your thing until you show them the screen. So while you are
yeah.
doing, you should try and talk. You should try and talk and explain what you're doing, but while continuously doing.
Okay. So what I'm thinking right now is it's I already forgot what's the term called, but it's transferring the dA and the dt, the dA and the dt, so that you can integrate them.
Okay.
Yeah. So I put the dA with minus 1 over Ka,
Mhm.
and then I separate the dt, and then I start to integrate.
Okay.
Yeah. So I'm integrating now. I think we understand what this.
Have you got anything yet?
Yeah, I'm working on it now. Wait, hold up. Power minus T. I think something like this. Sorry, I just doing it. Papers. I just made results.
So you're missing a constant. When you integrate stuff, don't you get a constant?
All right. Oh God.
Those are common thing, huh? Okay. So how do you find the value of
So-
constant?
So yeah, it's just
Yes. I know you have a constant. So what is the constant there? What's the significance in this situation? How in the world are you gonna find the value of this constant without me
So-
giving you more information?
Wait, let me think. Mm, so no information was given.
You think that information must be given? Okay. The information must be given if you don't know what x or y meaning is. But in this case, you have the meaning of the two variables. What are the two variables? One of them is time, and one of them is concentration of A, which is your reactant. So when you think about time, and this is a reaction of A going to B, what happens when your time goes to 0? That means at the start of a reaction. What do you know about the start of a reaction? What is the concentration of A?
Mm, concentration in the
Sorry?
start of the reaction. The concentration of A would be, I guess, the given concentration. I guess.
Exactly. So you just let it to be A naught. It's a constant. So it's the concentration of A, and then you just put a 0 at the very bottom. So it must be the initial concentration. Hasn't reacted.
Yeah.
There you
Yeah.
go. There's your unknown. You get it? So when you put T equal to 0, then you just get the constant being ln of A naught, right? Which is the logarithm of the initial concentration. So now write me the full equation now, and then express concentration of A as the subject. So make concentration of A the subject.
Oh, right.
You should be able to work through this a bit faster, yeah? Get it?
Just be this.
Well, the video quality is really bad. I can't read anything at all now. Is your internet connection okay? Because I can't read anything at all. No. No. um, did you? Can you see this?
Yeah.
Can you see this?
Uh-huh. N-A.
Do you see that?
Hold up. Hmm?
Is it clear or?
Wait, can I look on the top?
Let me
the
just
top
take a
part?
quick photo of it. I should be able to take a quick photo that will be better.
Yeah.
Sure. But yeah, something is wrong with your integration, man.
Oh. You mean
I
from this?
think.
I mean, I have to check. I can make careless
So the photo is being sent. So have a look at it and then see where you've gone wrong. Because this is a classic first order differential equation. Yeah. And then it's going. Okay. Check your Skype. Check your Skype for messages. Did you get a message?
Not yet. I haven't received any.
Yep. If you just open up, the file, is it clear?
Let me see. All right.
Did you find out where you went wrong?
Yeah, careless mistake.
There is no such thing as a careless mistake unless you did not learn from previous mistake before. Okay. There's only so many mistakes that you can make in life that includes in an interview. So when you are prepared, you shouldn't be nervous, and you should be able to think well, irrespective of the day, irrespective of who you're talking to, irrespective of whatever you're doing. What you know is what you know, see, unless unless you're careless, I suppose. So once you get that, do you see that expression now? Can you see where the expression goes? So it's a concentration of A equal to the initial concentration times e to the power minus kT, right?
Yeah.
Okay. So tell me, what is the concentration of A when T equal to 0? Based on that equation.
Wait. Minus kT. Which one's
the final one? Do you get the final equation already?
I haven't finished working on it actually.
Oh, okay. Cool.
Yeah. Let me finish it actually.
Okay. You're fairly slow with maths, by the way. Okay. These are standard first order differential equations from A level actually. It's just that in A level maths usually they do y x instead of using concentration or using time. But I'm sure you've seen this before in like past year paper question in maths, not in chemistry or biology.
Yeah.
In maths. Okay. Cool. Do you get the first order differential equation now?
Yeah. I got it.
You get the expression now?
Yeah, ln A equals to minus k t plus e. So when t is 0, it will be ln A.
Really?
Wait.
The concentration of A when T equal to 0.
Oh, concentration of A when t equals to 0.
Make A the subject. Do you get A as a subject already? So A equal to...
So it will be... Wait. So it will be e power c.
No. Have you gotten A equal to A naught e to the power minus kT already?
No, I have only been to the ln A equals to minus kT plus c so far.
Oh, right, okay. Okay, no wonder you haven't gotten to that bit, yeah. Stop rubbing, man. Stop rubbing. You shouldn't be rubbing. You should just continue. Stop using eraser, and not everything can be rubbed away, okay? In an interview, it's a one-time thing, okay? If you get passed to that, just like in your final exam, it's a one-time thing, one shot, one chance only, yeah? One chance only. You gotta go in with that mentality of not thinking you will make a mistake, and not thinking that there's always a next time, okay? Anyway, continue that expression. Come on, just get to that final one where you make A as a subject. You finished already?
Oh no. And
What's the problem? You cannot get it?
So I'm actually kind of stuck. So when t is equal to 0, so c will be A, right?
No. When T equal to 0, what does it mean? It means that your A, the concentration of A will be equal to A naught. Therefore, your C is equal to ln of A naught.
Okay, so
This is what I meant. This is what I meant by just now. You see, we talked through this. You were concerned that you have no value for the constant because you are not given the value. But in this situation, because it's a situation of time and concentration, and we know the meaning, we know the meaning at t equal to 0, A hasn't reacted, and therefore it must be the initial concentration. I'm sure you heard of this word, initial concentration method, right? In chemistry.
Yeah.
That is where my A naught come from.
I was wondering.
It's okay, as long as you know enough.
So expressed in terms of A, right?
Yeah.
Okay. So it'll be A equals to A naught e power minus kt, right?
Yeah, you got it finally. Okay.
Yeah.
Now sketch me the graph of concentration of A against T.
A against T.
Yeah, concentration of A against T.
Using this equation?
Yeah. Based on what you just derived. Of course, it's always based on your expression. What else would I ask you to derive it? So maths, a bit of differentiation, integration, a bit of drawing graph, and then we can talk.
Oh.
And it's already 40 minutes. One interview is only 20 minutes.
So I'm guessing the A will be the y-axis and the A naught will be the x-axis.
Sorry, what's the x-axis?
A naught?
No. A naught is a constant. It's a value. It's the concentration of A when t equal to 0. It's a constant. How can it be the x-axis?
No, never mind.
Hey, listen. I want you to draw the graph of the concentration of A against time.
Oh, against time. Right. Okay, I see. Against time. So wouldn't it wait, let me see. So isn't it just simply
I don't know, you show me.
okay, sorry, can you see?
First of all, you have, it's actually concentration of A, which is square bracket. Secondly, you have drawn into the negative region. And what does the negative region mean in this case? Does it mean anything? Can time be negative?
No.
Okay, you haven't taken into account maths and science. So when we put a physical quantity to a axis, they have a meaning, and that's why they are boundaries. And t is greater than or equal to 0, because t is less than 0 does not have a meaning, unlike x is less than 0. So what is the y-axis then? Actually, what is the y-intercept? Sorry, what is the y-intercept?
Y-intercept. Oh.
Yeah, you have drawn a graph, right? So what is the y-intercept? Do you know what is meant by y-intercept?
Y-intercept will be the concentration of the initial A.
Yeah, exactly. A naught, right? Okay. So you have drawn an exponential graph. Do you agree? You have drawn an exponential decay, right? Okay.
Yeah.
What order of reaction did we say this was? when we started this equation, you wrote a red equation, right? What
Yeah.
order was it?
First.
First order, right?
Yeah.
Okay. Did I ask you to draw a previous graph just now?
Yeah.
When we first started, what did I ask you
Yeah.
to draw? I asked you to draw how the concentration of A would change with time for a first order reaction. What did you draw me just now? Is it the same graph or different?
Straight line.
Different,
It
right?
was. Yeah.
So which one do you think is correct?
The second one. The curve.
The
The
curve,
exponent.
because it was straight from the model, it was straight from the maths that you do, and you know from this curve, you know the half-life will be constant because it's a first order reaction. Yeah, okay. The half-life is constant for this. So what you have drawn just now was actually for a zero order reaction.
Yeah.
Okay.
Yeah.
Anyway,
Zero.
I want you to try and get to that by doing the same thing, but assuming it's zero order with respect to A. Can you write me a red equation where it's zero order with respect to A? So how would the red equation look like? Let's do the same thing, but for zero order. This should be a lot easier. So assuming it's zero order, yeah? Assuming it's zero order, so your red equation will have red equal to,
K A power 0.
which is equal to,
K.
okay? So again, it's how the concentration of A is changing with time. The fact that it's zero order with respect to A does not mean that concentration of A does not decrease. It's still being used up. It's just zero order, right? So by doing a differential equation, then your red is still equal to minus dA over dt. Can you then derive an equation for how the concentration of A will change with time for this zero order reaction?
So I've derived that one is 1 over delta T. Okay.
Come on, talk through your thought process. Don't just leave me stranded here. Are you done?
Sorry, so
It's okay.
no. I've only derived to 1 over delta T dt equals to minus dA.
Oh, okay. Come on, do a lot faster.
Yeah.
It's a zero order equation, so it should be a lot simpler.
Very describing.
Are you still there? Hello? Are you still there? Can you hear me? Are you still there? Hey Alan, I think you got disconnected.